Hello and welcome to EGN3613 Engineering Economics. And now we're going to add another option to our interest formulas. In case you remember, if you recall, you had just a simple future value with present value. You had, then we added in a constant series, payments over time, either positive or negative. Then we were able to shift them in time, like off of a specific time. Now we're going to add in another one, gradient series. So what is a gradient series? Well, it's pretty simple. Gradient series is something that increases, in this case, it's a linear gradient series over time. So now, the first cash flow in the series, the gradient series, actually starts at time 1, even though the present value is at time 0. Just realize that there's an offset here. Also notice that the gradient series starts at the value 0. And what happens in a linear gradient series is the payments, or the amount that you receive or the amount that you put out, increases by a fixed amount every single time. So each time it goes up by G, 2G, so G, and then plus G, then plus G, then plus G, and on and on and on. And the gradient series present worth factor, the thing that's inside the brackets, is really the thing that changes. But the terminology changes because G refers to the concept of a gradient. Remember, A referred to the concept of an annuity. This line was constant. It didn't change at all. P always refers to that good old present value. Well, it's still an equation. It's a little bit more complex of an equation. What? You got 1 plus I at the n minus I times n minus 1 over I squared to the 1 plus I over the n. But it's still a pretty straightforward calculation. It's just an equation. Now, there is one thing about working with linear gradient series, and equivalency still applies. You can take a present value and see what it means as far as the equivalent of a gradient series. Okay. Now, but here's something that you have to look at. The gradient series might not start at 0. If the gradient series doesn't start at zeros, it's actually the sum of an annuity series and a gradient series with the gradient set to 0. So basically you have to shift the whole thing down so that at time 1, at the initial time, it goes to the G, the value starts at 0. Okay, that shouldn't be rocket science for everybody. You already know how to calculate the equivalencies, which, either present worth or future worth or whatever, of an annuity of A. Now all we're doing is we're adding in the concept of a gradient, but realizing that a gradient series has to start at 0 at time 1. So therefore, if you're going to do a gradient series that does not start at 1, you have to do both the annuity and the gradient and add them together. So some simple examples. What we're going to do in the examples is you can do these calculations. They are not that hard. The equation may be a little complex, but the concept is pretty straightforward. So let's say looking at this example, okay, in this case that increases by 250 each time, starts at 1,000 at time 1, and we want to know the present worth at time, the present value at time 0. We need an interest rate because you have to have that. And so what you're saying is, how much do you have to deposit if you want to get this out? So we need the P. Now, what do we know about this? We know that it doesn't start at 0. It starts at 1,000. So we're going to have to break it down into an annuity series and a gradient series to calculate. Okay? Or you can just do the interest equation for all of the values and add them together. Yeah, that's one way to do it. And if you got a spreadsheet, okay, It's not even more difficult than dragging and dropping an equation down through a line. And yes, get good at using a spreadsheet. I do not ever want to hear the excuse, I don't know how to use spreadsheets. Learn. Okay, that is one of the most important tools you're going to have as you do this is a spreadsheet. You do not want to do these over and over again with a calculator. No, use a spreadsheet. Okay, and in this case, it's really straightforward to do. And of course, you can use the financial equations that are built into the spreadsheet, or you can just type, put in the equation with the cells. Again, either way, you should be able to do this both ways. Again, with typing in the equation and using the financial equations. Okay, now, what's another way you can solve this? Well, you can break it down to the annuity series and the gradient series with the value starting at 0 at the beginning, calculate the P of each of those, and add them together. Again, equivalency. This is equivalent to a value at time 0. This breaks into these two that can be calculated to a value at time 0. Both of these added together are equivalencies. That's it. The whole concept is simply equivalency. Whether it's a single value, whether it's an annuity, or now in the case of whether it's a gradient. Okay? Not terribly difficult. Time value of money is not hard. It really isn't. People get really confused with it, but it's not hard. You are dealing with the concept of equivalency, and you just work. Each of the equations has specific conditions in which it works. Not that hard. So, concept of the super lottery. Do you want the cash option, bum, 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 or do you want the annual payment option where they say we're going to pay you $175,000 in year 1, and then we're going to increase that value by $7,000 each individual year for 26 years. And if you happen to die before year 26, we'll go ahead and give it to whoever you willed it to. Okay. So which is the better option? You can solve this. It's pretty straightforward. Well, got two ways to do it. Gradient series is going to have to, you can either just do all the calculations for each of the individual payments, calculating them all up. That's not hard to do with the spreadsheet. Hey, what does this look like when you do a spreadsheet? Okay. Either way, we're going to look at this and see, let's look and see what it is. Okay, so in this case, we're starting with 175,000. We're going to add in the 189,000. Okay, you put them all together, and we calculate the gradient by adding the two together, or we use a spreadsheet. Okay, either way, the value is going to come out the same. And by the way, which one is actually in the long run? Now remember, there's a couple of things that you need to actually think about in this one too, though. First, that option right there, the 3.44 million, the present value of the gradient series is actually worth more than the 3.44 million. You're probably going to have a high tax rate on that first 3.44 million. You're probably going to have a lower tax rate on each of the individual payments as you go along. That's going to be something, but there's going to be a cost of living adjustment that goes on with this too, which we aren't worrying about right now, but we're going to have to think about that later. Either way, if I ask you how to do the calculation, this shouldn't be that hard to do. You've got multiple ways to do it now. You can actually calculate each of the individual payments, bring them back to present value. You can calculate this as the sum of an annuity and a gradient series starting at 0, and it's going to give you the same value. You can throw the whole thing into a spreadsheet to do both sets of calculations. Okay, there you go. Yes, you're going to have questions that ask you to do this. And it's not the last of the gradient series. So in this last example, the amount of payment changed by a fixed amount every single payment. Well, a lot of times the change of the payment isn't a fixed amount of money, it's a percentage. And if it's a percentage, that is a geometric gradient. Okay, so one of the things that is a geometric gradient that you deal with all the time is just that, cost of living. Cost of living adjustment is usually a percentage. Cost of living goes up by bloop, up fixed percentage or a percentage each individual period. That is now a geometric series. So now we have another one called a geometric gradient. Well, in this case, again, you've got another factor. Now, if I is not equal to G, that top one is the way that you do the calculation of present value. Okay. If I is equal to G, it's a different calculation. Also, there are two ways to calculate. Well, actually, there's more than two ways to calculate. There's actually three ways to calculate. So 4 ways to calculate. I'm actually coming up with 4 different ways to calculate this. Okay, remember also the fact that you're dealing with adjusting for the 0, bringing it back down to a 0 value. But this is an alternate calculation for the present value. Now, I don't have you purchasing a book, okay? You need to find this equation on a regular basis. Well, one is you can write it down, but you don't have a book that you look it up in. You should, however, find, here's what I would suggest. These are all over the internet. If you Google how do you calculate the present worth of a geometric gradient series, it's going to give you the equation. If you have to do it of a linear gradient series, it's going to give you the equation. If you're going to have to do it of an annuity, it's going to give you the equation. You can get all those equations. Okay, it's just a way to not have to use a book, or you can just simply write them all down. So in this situation where you've actually got a gradient series, this is one called a cost of living adjustment. It's a very common one. You have a certain amount of money that's going to come to you in a pension. Pensions are typically a fixed amount of money over a given number of years. It's an annuity. So you're getting money in. Now, in year 1, if your expected cost of living is a specific value, that expected cost of living is probably going to increase by a fixed percentage, or not, it won't be a fixed percentage because cost of living never goes up by a fixed amount, but it's going to go up by an average amount over time. And you can actually kind of judge that by looking how much it has increased percentage-wise over time. If you're not sure, just say, what is a good average cost of living adjustment for the period between 1985 and 1995, or whatever period that you want to have, or what period should I look for in the future? Either way, you need to be able to compare these two to even know if the pension is going to make a lot of sense. You've got money coming in the pension. You've got money going out in cost of living. Now, the money going out in cost of living is eventually going to exceed your pension, but do you actually have enough in the pension to be able to handle this? Are the present values of both of these the same? How much money do you need to have in that pension in year 1 to be able to do this? Well, it's simply an equivalency. Look at how much you need to actually have at the present value. So without a cost of living adjustment, you can calculate how much you need to have. With a cost of living adjustment, you can calculate how much you need to have. In this case, we simply compare the two to see how much you need to have, okay? And how much more money you need to have to actually handle that expected cost of living adjustment. Major points. The interest equation has a time value. you can go look at present, you can look at future, you can look at the value at the time that you have the money. You've looked at annuities, you've looked at a series of equal payments, equal values. You can adjust easily for a specific point in time. Now you've looked at a linear gradient, which does occur. And now you can adjust for a specific point in time. It's relatively straightforward equations. And you've got the concept of a geometric gradient, which also occurs because we've looked at a specific scenario where it occurs, the good old cost of living adjustment situation that we showed you here in this example. Again, you can easily calculate a specific value at one point in time. Now, all of these made a bunch of assumptions. One is that interest rates stay constant, and that is not always the case. And yes, we do have to deal with these other types of cases, but the basic monetary equations, equivalency, 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 equivalency. Can't say it more enough. Just use the equation to calculate an equivalent point in time. Okay, you've got some examples here that I've given you so that you can test this out, and it's easy to ask for other examples, because what you're going to do is you're going to put these in as equations into spreadsheets, or maybe even put them in as equations into your calculators, and business calculators do this, and be able to do all these calculations. I expect that should be relatively straightforward for everyone. But if you've got questions, I understand this implicitly, so I can help you. On out.